CBT Nuggets JNCIS Security Series Security Policy Basics Part 1. Well, this is the first of two nuggets that cover security policy on the SRX gateway. And these are a couple of very, very important nuggets. Let's start out, first of all, looking at a definition and defining what security policy exactly is. Well, in a nutshell, security policies are really just rules that define the way that traffic can transit or go through your SRX. It's at the heart of the services gateway functionality. It basically provides a variety of tools for network administrators to control their different business processes. Because think about it, usually the transit traffic on the SRX is moving between different zones that are business zones. Even if it's a nonprofit organization, your business is broken up into different categories, different units, different departments. So we want to control what applications and services can flow and what types of data can flow between different business units, different floors of the building, different departments, different parts of the campus, or what can flow from the outside untrusted internet to the inside corporate LAN. It helps us enforce rules for this transit traffic between the zones in our Junos OS stateful firewall. You know, that's what it is. It's basically a stateful firewall which is maintaining a state of the flows that move through the device, and it's using the Junos operating system to do it. So traffic that enters one zone, okay, and that's the from zone, and exiting another zone, and this should say to zone, let me fix that. There we go, much better. So traffic that enters one of the zones, which is the from zone, and exits another zone, the to zone, we call this a context. And so basically, we're applying these firewall rules to contexts. For example, the from zone could be the trust zone, and the to zone could be the untrust zone, one of the most common contexts that we use on the SRX. So these policies, also referred to as firewall rules, are going to work best when we use custom well-named zones. What does that mean? Well, number one, you might not even call the trust zone the trust zone. You could call it the corp zone. But you could create zones for different business units or departments, like the accounting department, the HR department, R&D department, the management VLAN, okay? And so when you have your own customized, well-named zones, it allows you to build an understandable policy for the traffic that's flowing through your SRX. And of course, it depends upon where you're going to deploy this device in your organization. At the enterprise edge of your organization, or between, let's say, the call center in your corporate LAN, or between departments, or between buildings, or between floors in a high-rise. There's lots of ways to approach this. But the bottom line is, this is our tool set to control our traffic flow between our different zones in a stateful fashion. Okay, so there's 6 major security policy components. You have the source zone, we've already talked about that. The source zone is referred to as the from zone, and usually in most situations it's going to be the trust zone. The destination zone is the to zone. Often this is going to be the internet, okay, for most, especially in our environment, but it could be, you know, the call center, for example. The policy is basically a named object. It's a descriptive identifier that's assigned to the policy. So this could be something like, you know, allow users, you know. What are our internal users allowed to do from the from zone to the to zone, for example? There's the source address. This is the source IP version 4 or IP version 6 address. There's a destination address, which is an IP version 4, IP version 6 destination. And by the way, these addresses here, these are going to introduce a topic that we're going to look at here in a moment called address books. Address books, which are basically IP addresses, and then groups of IP addresses are going to be address sets. And for you Cisco people, this is a lot like network objects and group objects, okay? Or the grouping philosophy that we use in Cisco devices. And then the 6th major policy component is the service or the services. Now, a lot of times we'll just say any service, okay? But you can also be specific. It can be a single port, like port 80 for HTTP, or port 22 for secure shell, DNS port 53, or it could be a range of ports for different applications like conferencing and video and audio streaming services. So now that we understand the different components, let's talk about the way that policies are processed, or the nomenclature or syntax of the policy. Okay, implementing a security policy on the SRX gateway is just doing a simple little program. Okay, it's an if, then else statement. In other words, if traffic A is matched, okay, and we can match based on different criteria, or we can identify the traffic based on different attributes, okay? So if traffic A is matched, then the action B is performed, else we're going to drop the packet by default. That's the default action. So you could say it this way. We're going to classify or identify the traffic with an if statement. The action we're going to take is a then statement. Or we could do it this way. The match statement is the if part of it. Okay, we're going to match something based on different criteria. Then is the action we're going to take. And then there's an explicit deny all at the end. In other words, if nothing matches and there's no policy action, then we're going to drop the packet by default. Okay, let's look at the first part of the equation here, the if portion. Now, the if portion is accomplished with a match statement in the CLI. So what can we match? Well, we can match 5 things. We can match the source zone, so we're identifying the traffic based on the source zone or the source IP address, IP version 4, IP version 6. Or we can match on the destination zone or the destination IP address, IPv4, IPv6. We can even match on the application. This could be a custom service, which could be a custom set of port numbers, or it could be predefined. Source ports, destination ports, the protocol we're using like www, even a timeout value. So the application can be a wide variety of different attributes. But these are the main things that we can match on. This is the if portion, matching the source zone, source IP, destination zone, destination IP, or the application. Now, if there's a match, then is going to kick in. Let's take a look at that. So, if there's a match, we can deny, which is to silently drop the packet. Or we can reject, which also drops the packet, but it's going to send a TCP reset to the sender. Now, often we want to choose the deny option as opposed to the reject option, because this sending of a TCP reset back to the sender can actually be part of a denial of service attack. It can also be part of reconnaissance, as a malicious user is trying to do fingerprinting of this device, and based on receiving TCP resets, it can discover information about our gateway. So often we go ahead and we select deny over reject, even though there are some exceptions. Now, don't worry. We're going to look at several examples coming up. So right now we're just understanding the syntax and the logic of what's going on here in a security policy. We can also take the action of permit, which is allow the packet. Another action we can take is to log, create a log entry for anything that matches with the if statement, right? Remember, the action we're taking here is only if packet A or traffic A is matched. Another action we could take is to count, okay? That's accounting information for the session. And that can be some valuable information for auditing, for ongoing monitoring, optimization, gathering statistics, okay? So you can see there's quite a few actions that we can take here. And by the way, they're not mutually exclusive, okay? We could deny and log, or permit and log, or permit and count, right? So we can take more than one action. That's the second part. The third part is the else, okay? There's no match. No matching criteria, no match, so we're going to have an explicit deny, or we're going to drop the packet. Now, the reason I use explicit denies, that's a commonly used term in the access control list of Cisco. So if you're familiar with Cisco ACLs, then you're familiar with the explicit deny all at the end of the access control list. Same thing here. Now, another reason why it's so important to understand this syntax and the schema here is because you can have hundreds or even thousands of policies configured on an SRX device. It depends on your platform. On a lower end platform like this SRX 210, for example, maybe only, a handful. But you get into the larger enterprise devices, we're talking about up into the thousands. So we need to kind of understand some of the rules here. So when a packet, let's say here's a device and here's a packet coming inbound or ingress. As the packets come ingress, here's my little packets here, on the SRX, they're going to be evaluated against these policies, but in a top-down fashion, okay? And until all of those elements are matched, right? Remember, source zone, source IP, destination zone, destination IP, or application. If a match is found, then it's going to be done what it's told to do immediately. So as soon as there's a match the action is taken. In other words, it'll stop evaluating through the rest of the policies, which tells you that you can have multiple policies, right? Here you can see we've got policy 1 and then policy ... So 2, 3, 4, 5, however many policies. Now, if the evaluation, which is going top down, reaches the last policy and there's no match, then the else is going to kick in, and we see that's the policy default or deny all. Now, there's a rule of thumb we have to understand here. So, rule of, and then here's my big thumb. Okay? Here's the rule of thumb. You want to have your most specific rules at the top of the list, and then the most generic or open policies at the bottom. And the main reason to do this is you want the specific things to happen first. It's going to improve performance. It's also going to reduce the possibility that you'll have what we call shadow actions, or you're shadowing a more specific match criteria with a more common one. And again, we'll look at some different examples here. Now I want you to notice the context lookup that we're looking at over here on the left-hand side. Now the first thing that's basically determined is what is the from zone. Okay, now the from zone is easy because remember the traffic is coming ingress on an interface, right? We talked about that, and we know that the interface is associated to a zone. So that first piece of information, in other words, what is the from zone, that's easy, okay, because it's coming to the interface and it's assigned to the zone. But then it has to do a route lookup, right? Once it determines the destination zone, and that's what makes it context. So remember, the first thing here is this kind of context lookup, the from zone and the to zone. Well, the deal is this. Once we determine what the to zone is, once we determine the destination IP address, for example, we have to know what zone that destination IP address is assigned to. So there's going to be a route lookup that's created first. Once we do the route lookup, we know what the destination zone is. We can now generate our context. And so you can see several examples of different contexts here. You know, the from zone trust to the zone untrust, or from the untrust to the DMZ. There's just examples. From the trust to the DMZ. Or maybe you've got your own named zone, from the zone call center to the zone corporate LAN. And again, the route lookup, which looks at the IP address of the interface associated with the zone, is what helps us create this context. Once we have that context, we start applying the policies based on the criteria that I gave you earlier. As soon as there's a match, boom, that's the action that's going to take place. Now I gave you your default actions, remember? You know, logging, denying, permitting, but there are other more complex actions we can take. And we're going to learn about those later on in this Nugget series. For example, one of the actions we take could be IDP, intrusion detection and prevention. We could also do another advanced action, which is UTM, Unified Threat Management. This is often referred to as Deep Packet Inspection, DPI, or it's also referred to in other vendors as AIC, Advanced Inspection and Control. In other words, we're going to permit and deny based on granular information within the actual application or service itself. Because remember, multiple actions can be configured inside the then statement. In other words, you can take multiple actions, and I alluded to this earlier. They're not mutually exclusive. Okay, there's a couple of ways we can look at the existing security policy on your SRX 210. In operational mode, I'll do a show security policy, and we can see we've got a default policy called deny all. We talked about that. Remember, that's the default or the else, right? Our from zone is trust. Our to zone is untrust. So we've got a default policy which is trust to untrust. It's enabled. And we've got, this is kind of showing, this is the first one in the sequence here. The source address, any source address in the trust zone to any destination address in the untrust zone using any application with action permit. And of course, there's that else statement, which is the default deny all. But of course, we're pretty much permitting all, so the implicit deny all here, the default policy, is not going to be hit in this particular instance for traffic coming from the trust zone to the untrust zone. Now we'll test this out in the next nugget to try some different applications to show how we can deny some traffic from the trust to the untrust, just to see it in action as well as some other case studies. Now if I want to get into the configuration mode and I want to take a look at some policy information there, I can get into the context of edit security policy. In this context, You can see that by the square brackets, right? Here, we can just do a show command, and we're going to see it, of course, in our kind of scripting-based format, right? Where we have our policy. Well, first of all, we have the from zone trust, the to zone untrust, and then the curly braces. And the policy is trust to untrust, and here's our match statement. So this is the if. Okay, so if the source address is any address, or the destination address is any address, or the application is any, then okay, the action is to permit. And of course, we have a default. We don't see it here. There's an else, and the else is to deny all. We don't see it. It's implicit. Now, when we're creating our own policies, we're doing them, manually. We can, of course, we can get much more elaborate by having, for example, multiple policy entries. We could have also explicit else statements. So, else could be doing something else besides denying, right? And we'll get into that, right? This is a major aspect. If you took the JNCIA course, which I'm pretty sure you did, I hope you did. If you didn't, if you have a chance, go take a look at the JNCIA course, because on my router, I did several different policies that used all these constructs, the match, then, and the else statement for different scenarios. Now, the last topic I want to look at in this particular nugget, part 1, before we get into kind of the real application of policy, is talking about address books and address sets. Now, generally, I don't do a lot of comparisons between Juniper and Cisco as we go along through here, but this one, it's just so obvious that I just can't help it. For you folks who've worked in Cisco before, specifically on the adaptive security appliance, you're probably familiar with what we call network objects and network grouping. And we use those grouping of networks and objects and services, and we name them and we relate to them, or we invoke them in access control lists and classification ACLs, in network address translation rules, so on and so forth. So this is really the equivalent, okay? Personally, I'm not a really big fan. This is one of the things that Juniper does that I'm not really a big fan of. I don't like the whole address books and address sets things, because it's a little bit complicated or not that easy to describe. An address book is a collection of addresses and address sets. Okay, so the book is the large container that collects the addresses, which can be, a specific IP address. It could be in a prefix format. For example, get my pen here. Something like 1.2.5.0/24. That CIDR representation, that prefix, is perfectly acceptable. Okay? Anything that translates into a network prefix is acceptable as a network prefix. However, you couldn't do something like 1.2.5.4/24. Okay, that's not an acceptable network prefix. Okay, so that's a no-no. It basically is exceeding the subnet length of 24 bits. So everything that goes beyond the subnet length has to be entered in as a 0. If it's a host name we're talking about, like 1.2.5.4, then you would have to do /32. Okay? So we don't represent these in the same way that, let's say, that we would input this IP address in the TCP/IP properties of a network host, for example. If you were going to go and configure your workstation in the TCP/IP properties, this would be acceptable. 1.2.5.4/24 or 255.255.255.0. That's okay from the client perspective, from the host perspective. But from the perspective of Juniper or Junos, it needs to be either a network prefix, or if it's going to be a host, it's going to be /32. So the address book is a collection of addresses and address sets, and these are reusable components. Just like we did them in Cisco, they're reusable here in Junos. They can be referenced in security policies. They can be referenced in NAT configs, network address translation, which, by the way, we're going to be looking at in the next couple of nuggets coming up after security policy, and other things as well. And address book entries are host addresses /32 and subnetworks or prefixes. And these reusable blocks can then be permitted, right? You can permit the host or the entire subnet or CIDR prefix. You can block it. You can NAT it. You can network address translate it. You could encrypt it. Okay, you could say we want to apply some type of protection, cipher protection, encryption, authentication mechanism, or you can even user authenticate a particular host or subnetwork. And the address book can be a combination of IPv4 addresses, IPv6 addresses. It can even be wildcards that represent, multiple addresses, as well as DNS names. Okay, as long as you have name resolution. And there's actually 3 predefined addresses. We've already seen one of these. Okay, there's any, and you can get even more specific, any IPv4 or any dash IPv6. And that's a dash right there. So any IPv4 and any IPv6. Like I said, we've already seen these. For example, if we do a show security policies here, this is a predefined address, any. And we also saw this, of course, when we drilled down into the configuration, edit security policy, did a show there in the hierarchy. We also saw any used there as well. So, that's our first taste of a predefined address. By the way, I just typed this in here. This is not a command, but this is showing you a potential IP version 6 prefix that could be an address, right? And so if you go back to the JNCIA series, I added a value add nugget onto that series towards the end on IPv6 in Juniper. So you might want to refer back to that one for a discussion of IPv6. Now, as I mentioned, you can use wildcard addresses in these names. Let me go back to the whiteboard here. Now, I mentioned a while ago that you can also use wildcards and wildcard masks in your address books. So, for example, you can use the wildcard masks to represent particular ranges, or you can, wildcard particular things. So, if we have A.B.C.D format / wildcard mask, our example here would be 172.16.0.11 / 255.255.0.255 is basically wildcarding that third octet there. So this could basically be anything. So, and this is kind of an interesting one because you're saying anything that's the .11 address on the subnetwork. So 1.11, 2.11, 3.11, 200.11, all of those would be valid. Okay, so you can use this kind of wildcard masking to represent a particular range of subnetworks. The SRX also has a global address book, and it can also be a combination of things like IPv4, IPv6, wildcards, DNS names, and you can create addresses in this global address book, or you could use predefined addresses, any IPv4 and any IPv6. And the global address book is available to all security zones that have no address books attached to them. So what does that tell us? Well, we attach address books to security zones. Now, an address book can get really large. And, if you imagine in a service provider or a large metropolitan area network enterprise, we could have a huge number of addresses and prefixes and wildcard addresses, and so it can be cumbersome. So we can take these groups of addresses and make them into address sets. These address sets allow us to manage large address books. With a set, you can then organize your addresses into logical groups. And then if you think about it, it's kind of like doing summarization at different aggregate levels of your network hierarchy, right? Maybe you're using variable length subnet masking. So we can use these address sets to organize our addresses into logical groups, geographic groups, departmental groups, and it allows us to configure these other features like security policies and NAT translation rules. Okay, so since we have some hosts, a bunch of hosts inside Nugget Labs here, in the trust zone, we might want to go ahead and create some address book entries for those. We also might want to group them up, maybe group up some PCs, group up some internal servers that we're going to be using in our security policy, that we're going to be using in NAT translation rules, maybe user authentication rules. So we want to get into the edit security context. And here we'll do an edit zones security zone, and then what is the zone we're going to do? Trust, or depending upon the environment, this could be the DMZ, it could be the accounting department, it could be the call center, whatever, if you have your own custom zones created. So notice that we're in the edit security zones, security zone trust context now. So we're going to set an address book entry, and the address object is going to be Nugget Lab, so NLPC001. Okay, so I've got, let's say, asset tags that I've stuck on all of my workstations and servers, and of course maybe I'm using a spreadsheet and I'm matching this up to the spreadsheet of assets in my organization. So Nugget Lab PC001, and then the IP address that one's going to have is 192.168.1.100. Now, of course, in an environment where you're going to have hard-coded IP addresses, this is workable. If it's possible that this is a laptop that could get a different DHCP client address, well, this won't work for us. But usually if we're going to be doing, let's say, servers, internal servers that we're going to expose out to the internet, then that would be a excellent candidate for this type of thing. But we'll go ahead and do another one, just kind of give you the idea of how this works. So we want to do PC002, and we'll say that's at 192.168.1.101. Okay, let's do a couple of servers here, which are really would be more common. Servers in the inside trust zone, servers in a DMZ or some kind of public zone. So let's say this will be NLSRV001, and we'll make that 192.168, a little fat finger going on here, 168.1.50, and then we'll do another one. This will be server 002, and if it's, you could have another naming scheme. These are web servers. It could be NLWWW001, however you want to do it. You definitely want to have a kind of a well-established naming hierarchy and structure, well-documented, systematic, maybe part of a SharePoint document library and all that kind of good stuff. You want to have good asset management. So 192.168.1.51 is that server. Okay, so we've got a couple of PCs that are address book entries and a couple of servers that are address book entries. Now, let's go ahead and decide, well, we might want to group these up, because it's one thing to invoke, NLPC001 in a security policy or a NAT policy, but it would be easier just to group these servers up, okay? So let's go ahead and just group those servers up. Make sure we're in the right context. We are. So we're going to set, this is going to be an address book, but this is going to be, and we can see our options here, this is going to be an address set, right? Talked about that. And usually in a small organization, you may not use address sets, but even grouping up, let's say, 3 servers into an address set can save you quite a bit of real estate in your policy. So let's do an address set. Okay, let's go back up here, and we want to call this what? Nugget Lab SRV. How about serve? How about servers? How about that? NLSRVS. Let's just keep it like that. NLSRV, Nugget Lab servers. That's a address set. Okay, and so what are we going to add to this set? Well, how about NLS server 001, right? So NLSRV 001. We'll add that to the set, and it didn't like that. Let's see what we're going to do here. Got my set name, and then need the address, NLSRV001. There we go. And we'll add to this NLSRV set RV002. There we go. Now we can do a show here, and we can see here's our address book. Okay, we got 4 entries in our address book. We also have an address set, which is made up of these 2 servers. So if we want to create a policy to allow certain traffic to come to this server, let's say from the outside, from maybe it could be ultimately somebody at a remote office teleworker, we want to give them exposure to these two servers. Well, we can just represent these two web servers, for example, or FTP servers, just by this address set name, NLSRV. All right, there we go. So address books, which are basically just an address book, global address book, and here's our entries, right? And then address sets, which are groupings of address book entries, all right? Alrighty, in JNCIS Security Policy Basics Part 1, we looked at the basics. We defined what a security policy is and why we'll use it. Talked about the syntax, the flow. We verified the default policy a couple of ways at the operational prompt, also in configuration mode. And then we finished up looking at address books and the entries in the global address book and address sets. I hope this CBT Nugget's been informative for you. I want to thank you for viewing. We'll see you in Security Policy Basics Part 2.